Take a look at this question in front of you. It's an AMC 12 question, question 22. And it looks pretty challenging because we're asked to compare lots of different things like p of -1, the product of the zeros, the non-real zeros, the coefficients, the real zeros, lots of different stuff over here. And all we're really given is this one graph and then a little bit about its equation and not a whole lot. So how do we solve this? Well, this is a very, very good test of if you can actually understand polynomials, because there are a lot of core concepts that come up over here and you have to be able to apply them. So with that being said, pause the video right now, try this yourself and comment your answer down below and then watch the rest to find the correct answer. All right, so let's start by seeing this very quickly. The graph below shows a portion of the curve defined with the quartic, and then yeah, that's a degree 4 quartic right there. Which of the following is the smallest? So we want to find the smallest of these. And let's start off with p of -1. That's pretty easy. P of -1 will just be this value right around here. So this is roughly like, it's what, 4, 6, 8. So maybe it's 4.5. And that's probably the best way to do this. Just write the rough estimates. They don't have to be perfect. But just write them near the option so you can easily compare. The product of the zeros of p. Well, just from Vieta's formula, we know that the product of the zeros of p will be d, right? But what is d over here? Well, we don't know, right? But luckily for us, we can just say p of 0 is going to equal, well, this is going to be 0, this is going to become 0, 0, 0. So p of 0 is equal to d, which means d is just equal to, and then we can look at it over here and we'll see that it's about 5.5 maybe, something like that. That's the product of the zeros. Now, what about the product of the non-real zeros of p? Well, to do that, we just need to look at the real zeros of p. And how many of those do we have? Well, you can look at the fact that we've got 3 turning points. So that means that there aren't going to be any more zeros. It goes up here and up from here. So all the real zeros will be visible to us over here. One of them is about 1.5. One of them is about 4. Multiply them, you get about 6. And in total, they only multiply to 5.5. So roughly speaking, the product of the non-real zeros will be only about 1 or so. So it's obviously different and much less than 4.5 or 5.5. Some of the coefficients of p, super common thing that comes up all the time. It's just p of 1, right? P of 1. And so if you plug that in, it's just going to be 1 plus a plus b plus c plus d, which is what we want. And then over here, it's about this high. So that's like, what, like 4 maybe? Let's say 3.8. And now the sum of the real zeros of p. Well, what are the real zeros of p? We already found them. It's this and this. And that's going to be roughly, 5.6 or something. Clearly, all of these are a lot, A, B, D, and E are a lot bigger than C. So C is our final answer. And just like that, we've solved this question 22 in under 3 minutes. So if you enjoyed this, please make sure to subscribe. Hopefully this video helped you. And there are a lot more like this from all sorts of exams, AME, Stanford Math Tournament, Purple Comet Math Meet, so many other exams like that. So if you're interested in competitive math, make sure to follow along for more of this sort of stuff. Thanks so much for watching this video, and I'll see you in the next one. Bye-bye.